All right, we back. Like I mentioned before, we're going to do a couple of examples. One you'll do on your own, one we'll do right now. And so we're actually going to do the first example on the handout. And so we've stepped away from the note packet for a second, and you should be able to find this handout in the folder on Sakai. And the example we're going to look at is just a hypothetical example where we're interested in maybe the proportion of US preschoolers who can write their own name. So we get a random sample of 120 US preschoolers, and then we find that 34 of them can write their own names. So I made up this example, and I don't have kids, so I have no idea if this is accurate at all, but we're going to go with it. And we're going to kind of use this example to apply the definitions that we just wrote out about sampling uncertainty and point estimates and all that. And so our population that we're thinking about, again, that's specified by the research question. And so we're interested in the proportion of preschoolers who can write their own name. So our population is US preschoolers. All right, so interested in US preschoolers, our parameter, again, our definition that we had, that says that it's just a number that characterizes our population of interest, usually unknown. And so it's just a single number. In this case, it's going to be the proportion of US preschoolers who can write their own name. All right, so usually unknown because we don't really know the actual proportion of US preschoolers who can write their own name. And it's a single number. So even though we don't know it, this number might be 0.4 or 0.5732 or whatever. So it's just a number that we don't know, but we would know if we had the time and resources to take an entire census. Our point estimate for that is just going to be the best kind of guess for it that we got from our sample or from our data. In our sample, we found that 34 out of 120 were able to write their own name, and so our point estimate is just 34 divided by 120. You could do that on your calculator and actually get a decimal if you want, and so our point estimate is 0.283. So we don't know, that's not going to be this parameter of interest exactly, but it's our best guess for it from the sample that we actually took. And so the big kind of definition again is this sampling uncertainty. And so our definition for that was how much a point estimate will tend to vary from one sample to the next. In the context of this problem, all this means is that if we took another sample of 120 preschoolers, then our point estimate it would probably be a little bit different than 0.283. So our point estimate would probably be a little different than 0.283. This kind of makes sense. If we took another sample of 120 preschoolers, it doesn't seem particularly likely that exactly 34 of those preschoolers would also be able to write their own name. So how much this point estimate is going to kind of jump around if we took samples over and over and over again, that's what this concept of sampling uncertainty is getting at. Finally, there's a question about whether this would actually be feasible to get this random sample of 120 preschoolers. And so this would probably be difficult. And to get this random sample, that's kind of the hard part. Like, how would you uh, get a list of all preschoolers in the US? That's really what you would need to get this random sample. It'd be a lot easier to get a convenient sample and just go to like a local preschool. Even that would be a little bit tough given data privacy issues. But to get this random sample, it would, for this example, be pretty difficult. Okay, so you'll do this other example on your own and submit this handout to Sakai. As always, feel free to shoot me an email if you have any questions about any of this.